So welcome to s.mathguru classes. So our main discussion is inverse Laplace transform. We solve some problems. It was given some problems. Inverse Laplace transform of logarithm function, inverse Laplace transform of inverse trigonometric function. Now let us consider another types of problem. Find the inverse Laplace transform of number 1 twice a is by s square plus a square whole square. Number 2 s square minus a square by twice s square plus a square whole square. So this one we consider. Now solution is that. So since we know this formula L, L a by s square plus a square equal to a by this is a by s square plus a square equal to sine at. We know this formula. So again we know this formula in case of inverse Laplace transform of derivatives. L inverse fs equal to minus 1 by t L inverse dds of fs, this one. So if we multiplying by minus 1 by t with this, then answer is L inverse dds of fs we get. So we consider we multiplying this side is minus 1 by t, then this will be L inverse dds of a by s square plus a square. We get this is sine at. So this t multiplying on right hand side, and this is L inverse u by v formula or fx by gx formula. This is division rule. So this will be s square plus a square whole square, s square plus a square dds of a minus a dds of s square plus a square, and this is minus t sine at. We get this. So this is L inverse s square plus a square whole square. This is s square plus a square. This will be 0 a. This is twice s plus 0. This is constant, then 0. This is s square means twice s, and a square is constant. This is 0 minus t sine 80. So this implies L inverse, this is 0 twice as by s square plus a square whole square. This is minus t sine 80. Now this minus cancel on both sides, then this implies L inverse twice as by s square plus a square whole square. This is t sine at, and this is the final answer. L inverse twice as by s square plus a square equal to t sine at. Next we consider number 2. Number 2, we start from here. Number 2. Here given, this is the cousin of this problem. Same types of problem we have, but here twice as, here s square minus a square given. So we are taking, since L inverse s by s square plus a square, this is cos 80. We know this formula, s by s square plus a square cos 80. Again same formula using, if we multiplying this result by minus 1 by t, then we get dds. So we multiplying by minus 1 by t L inverse, then within bracket we get DDS because L inverse DDS S by s square plus a square, and this is cos at. We get this. Just this L inverse fs equal to minus 1 by t L inverse DDS of fs. So this is L inverse this. If we multiplying by minus 1 by t L inverse DDS of this. And this is minus 1 by t remains same, L inverse remains same. This is division formula, denominator whole square, denominator DDS of numerator minus numerator DDS of denominator. We get this, and this is cos at minus 1 by t L inverse. This is s square plus a square whole square, s square plus a square, ds is 1, ds 1 minus s, and this is twice s plus 0, and this will be cos at. Now answer coming soon, and this is denominator remains same, s square plus a square minus 2s square. This is cos at, and minus 1 by t L inverse s square plus a square whole square, a square minus s square. This is cos at. So this s square minus 2s square, this is minus s square. But in our problem, s square minus a square given. So multiplying this minus sign within this bracket and t on right hand side. So this will be L inverse s square minus a square by s square plus a square whole square, and this is t cos at, and this is our final answer, t cos at, our answer. Another problems. Number 1, find the inverse Laplace transform of 1 by s square minus 5s plus 6, and this s plus 1 by s square minus 6s plus 25. Now solution. First we consider number 1, L inverse 1 by s square minus 5s plus 6, and if we factorize this, s minus 3 s minus 2 we get. If we factorize, we get this. Now this is actually partial fraction method. If in case of partial fraction method, if numerator is constant, then we can write in shortcut method s minus 1 by s minus 3 and 1 by s minus 2. This is the shortcut method, and this is if we calculate this, s minus 3, s minus 2 is LCM. This is s minus 2 minus s plus 3, ultimately 1. If we recalculate, we get this one. So this will be L inverse 1 by s minus 3. So L inverse 1 by s minus 2. We get this. But you know this formula, L inverse 1 by s minus a. This is e to the power at. L inverse 1 by s minus a, e to the power at. So this is s minus a, e to the power twice t, e to the power twice t. So this is our answer. Very nice solution, very easy also. Next we consider second number 2, L inverse s plus 1 by s square minus 6s plus 25. This one you consider. So in this problem, so first we convert the denominator. This is not possible to factorize, unable to factorize, because this is 25 given, this is minus 6 given, which is not possible to factorize. At that time we convert in perfect square. S square minus 6s plus 25, s square minus 2 into s into 3 plus 3 square, 25 minus 3 square. So this 6s, this is 3 square extra, then minus 3 square. This cancel, ultimately we get this. This is a square minus twice ab plus b square. This is a minus b whole square. And 25 minus 9, this is 16. So we get s minus 3 whole square plus 16. We get this. But in denominator we get s minus 3 and numerator is s plus 1. 16 means 4 square, and numerator also we write s minus 3 plus 4. We get this. Because denominator s minus 3, numerator also we have s term. So we must have numerator denominator same. This s minus 3, here also s minus 3. But actually s plus 1 given, so adding plus 4. So this will be L inverse s minus 3 whole square plus 4 square plus 4 by s minus 3 whole square plus 4 square. Now we taking L inverse with this, L inverse s minus 3 by s minus 3 whole square plus 4 square plus L inverse 4 by s minus 3 whole square plus 4 square. We get this. So again you know the second shifting theorem, L inverse f of s minus a, and this will be e to the power at L inverse fs. So if we remove this a, then this will be e to the power at and f of s. Here s minus 3, we remove this 3, then we get e to the power thrice t L inverse s by s square plus 4 square. So we get this one. And from here also we remove this 3, then e to the power thrice t L inverse 4 by s square plus 4 square. So we get this one. But we know this formula, L inverse s by s square plus a square, this is cos at, and L inverse a by s square plus a square, this is sin at. So these are the formula we know. If s by s square plus a square cos at, a by s square plus a sin at. So this will be e to the power thrice t s by s square plus a square, this is cos at, e to the power 3t a by s square plus a square, this is sin 4t. We get this is our answer. Very nice solution, very easy also. Find the inverse Laplace transform of s cube by s to the power 4 minus a to the power 4. Now solution is that L inverse s cube by s to the power 4 a to the power 4, and this is L inverse s into s square, this is s square whole square a square whole square. We get this. L inverse this s taking outside, this is s square by a square minus b square formula, a plus b, a minus b. So we can write here minus and here plus, a minus b, a plus b. We get this. Now this power is s². If we write one technique, s remains same. If we write 1 by s² minus a² minus 1 by s² plus a², then what will be the numerator? In numerator we get s² plus a² minus s² plus a². So we get in numerator, if we write this is plus symbol, then s² plus a² s² minus a², we get s², a² is cancelled. So we get in numerator this s² plus a² s² minus a², a² cancelled, 2s², 2s² we get, but actually numerator is 1s². We get 2s² if we recalculate this. Then we write here 1 by 2 outside. 1 by 2 taking outside. So this will be 1 by 2, this is outside. Then L inverse multiplying by s by s² minus a², s by s² plus a². So we get this. Now this will be 1 by 2 remains same, L inverse s by s² minus a² plus L inverse s by s² plus a². So this is direct formula. S by s² minus cos hyperbolic at, cos hyperbolic at, and this is cos at. 1 by 2 cos hyperbolic at and cos at, and this is the final answer. So here we use some technique. Without technique this will be very long problem, solution will be lengthy. So this is the complete solution of the given problem we solved by shortcutly. So I hope you are all enjoying with me. If you are all enjoying, then please share the video to other engineering friends also, and they will get some interest, and like the video and click the bell icon. Thank you.